Okay, hello, welcome back. So this is the second part of the video. So you can see this is the educational kit, PWM versus MPPT charge solar charge controller educational kit. So basically you have a display here and you have a two potentiometer and a switch. So this is to control the light or sunlight intensity, and this one is to control the load. Okay, so this is PWM and MPPT. So top is PWM, bottom is MPPT, so you can just switch. Okay, so this is, be careful, this is not too tight, so don't take it out. Okay, so like I said before, you can look at the manual at the back. Okay, so to power it out, you can just use the power bank. Okay, so let me connect this. Okay, so when you connect this, automatically it will run. Okay, so we start with the PWM first. So you can see here, this is sun intensity. You can see when you change the sun intensity, it will change the current. Okay, mostly current. Okay, so if you turn counterclockwise, it will reduce the current, and when you increase the go clockwise, it will increase the current. You can see here the power, this is the voltage, this is the current. Okay, A is for ampere current and this is for the power. Okay, so basically you can control the sun intensity. Okay, so how about the load? So you can see here the battery, because the load is usually connected directly to the battery, the voltage remain the same as the battery. Okay, same here, because PWM, the PV also has the same as battery. So you can change the load. You can see counterclockwise reduce the current and clockwise increase the current. So as a result, you can see here the power can become up to 700 watt. Okay, so you can control the load and sun intensity. Okay, so what you have to learn here, okay, so you can see here voltage, current and power. W is watt for power, PV is PV, LD is load, and BA is battery. For battery, you have a voltage, you have current, you have the SOC, okay, state of charge. Okay, this one has problem actually. It should be 52%. This one I will repair later. Okay, it should be 0 to 100. Okay, and this one is the power. Okay, so you can see here the power for the PV and load is always positive value, but for battery you have positive and negative. You can see here when your load is increased a lot, it becomes negative. Negative means that the battery supply to the load, but if the battery is basically is discharging. But if the value is positive, okay, something like this, so positive current and positive power means that it is discharging. Okay, so I hope you can understand that. Okay, this one make sure I will repair later. Okay, 0 to 100. Okay, maybe I will repair with. Okay, I have repaired the percentage, just multiply by 100 actually. Okay, so this is what happened. So you can see here when the irradiance is high, okay, the load is low. Okay, so you can see here the battery is charging, so the percentage increase, and you can see here when the battery is charging, the voltage also increase. That is the characteristic of battery. Okay, so it's charging and the value of current become positive. You can see here 10 ampere. So basically all the current from PV goes into the battery because of the load is 0. Okay, you can on the load, okay, but the battery will, you can see here, it will reduce the current to go to the battery. So I reduce it back. So what happened is, I want to show what happened when the battery is full. The battery is full at 95%. Why we set like that? Because we don't want it to damage the battery. Basically it needs to be lower, but for this case I set to 95%. So what happened after 95%? Basically the PV switch will be turned open. Okay, when the battery is open, it become VOC. Okay, open circuit voltage at the PV. So basically open circuit voltage for this case is 50 volt. So basically it's open, so battery is not charged anymore. Okay, so that is what happened. It's just to protect the battery from damage. But what happened if I turn on the load? So you can see here, you have load, and you can see here voltage keep on and off. Okay, so this is if not mistaken, it's called floating voltage. Okay, for the battery. Basically it still supply load to the battery, supply energy to the load, but for the PV it keeps turn on and off. Okay, on and off. Basically when you can see here it's 95%, but after the load use it drop, and then the PV will charge again. So basically keep charging and discharging, charging and discharging, so it will maintain the voltage of the battery and prevent the battery from damage, but it will not deplete the battery. So the battery always keep on charging. Okay, so that is what happened. So what happened if the battery is depleted? Okay, so this one I increased the load to a lot. Okay, 7,000 watt. So you can see the battery drop significantly, and also the voltage drops significantly. Okay, when we should wait, it's okay because I set the battery is quite low. So you can see the battery will stop, if not mistaken, is 20%. Okay, same as before. If you don't want your battery to be damaged, you cannot just discharge everything from the battery. You need to set around 20%. Is also quite dangerous. You can damage the battery easily. Okay, so okay, it's already passed. Okay, so for this case, you can see here the battery is like this. Okay, okay, sorry about that. Okay, so you can see here the battery keep dropping. Okay, because the load is larger than the PV. Okay, so you can see here after 20%, what happened to after 20%. So you can see here all works properly, but after 20% suddenly the load is disconnected. This is to protect the battery from damage. Okay, and you can see because there is a PV, it start to increase, but the load still disconnect. Why we don't connect and disconnect, connect and disconnect the load? So basically it can damage your load. Okay, keeps connect and disconnect. For PV is okay, but for the load you cannot do that. So you have to set some reconnect voltage for this one, but for this case this is reconnect SOC. I set it to 50%. So you can see here after 50% it reconnect back. Okay, wait. So after that, see the load is reconnected and the battery start to fall again. Okay, so as long as the battery is still not fully charged, okay, let me show you later. Okay, so it dropped again to 50%, 20%, okay, and disconnected, but suddenly the PV goes out because of night, for example. Okay, so you can see here the load still cannot be used. So I turn on the load, nothing happened. So basically as long as it's don't achieve the reconnect voltage, or in this case reconnect SOC, it will not work. So you have to charge the battery first before the load can use the battery and the PV. So let me wait. Okay, so that is normally usually it's called the disconnect voltage and reconnect voltage in the solar charger. But for this case I use SOC because it's much more easy to understand. Okay, so wait until 50%. Okay, so you can see it will be reconnected again and the battery start to drop. That is how the PWM operate. Okay, when the battery is depleted. Okay, so for PWM MPPT, the reconnected is the same, usually the same. The difference is only when the battery is full. Before this, when the battery is full, is for the PWM is start to on and off like a PWM. So that's why it called PWM probably. Okay, so basically it's connect and disconnect, connect and disconnect. So what happened if I use MPPT? So Let me reduce this first. Okay, let us charge this. Okay, so now the load is now operate. Okay, so suddenly I want to change to MPPT. So before this PWM, you can see the voltage of the PV and the battery is the same. So what happened if I change to MPPT? So you can see here the voltage will become not the same. Okay, so that is what happened. Okay, so basically the voltage start to increase to the MP, the maximum power. Remember the graph I showed before in the theory part. So basically you can see before this is only around 200 watt, but 250 if I'm not mistaken, but because of the MPPT algorithm it increased up to 400. So that is the advantage of using MPPT. The power will be very high. Okay, so you can see here the voltage keep swinging. So this one is actually a PNO, perturb and observe algorithm, MPPT algorithm. So this is usually they will circulate, okay, oscillate around the maximum power. That's why you can see here the voltage keep change. Oh, sorry, this one is already full. So let me increase the load first. Okay, so you can see it keep swinging around that point. Okay, so something like that. What happen if the battery is full? So I reduce the load. Okay, so I reduce the load, battery will increase up to 95. Okay, so same as before. Okay, it will disconnect. So basically what happened, disconnect, battery voltage will become very high and the current become 0. It will become disconnect. Okay, so if I increase the load, it will be oscillating around that area. See, you can see this is oscillating. Okay, oscillating, and then it's called a floating voltage. If you check the charge controller, is basically floating voltage. Basically, it's try to float around the standard, the specific voltage. In this case, the SOC is around 95%, but in reality it will use voltage instead of SOC. So basically that is how the difference between PWM and MPPT. I hope you can understand this. Okay, if not, you can try to look at the theory first, okay, before you continue with this. So if I switch it, it will automatically goes back into the PWM mode, where the PV voltage and battery voltage is the same. If I switch back to MPPT, it will start to search the maximum power. It takes time, okay, because I already said it's very slow. Okay, so in reality it will be less than 1 second, but for this case it will be takes time around 20 seconds to achieve it. So you can see it's already achieved. It's around 40 volt. I said it is around 40 volts, so it's oscillate around that location. Okay, so that's it. Okay, I hope this can help you understand on how PWM solar charger controller and MPPT solar charger controller work. Okay, normally we just choose one. Okay, normally we just choose one. You cannot use both at the same time. This is just for learning purpose. Okay, that's it. Thank you.